Hello, today we're going to talk about how to do a list and linked list. A linked list can be visualized as a chain for nodes where every node is point to the next node. A linked list contains a list of elements called at first, and you can call it head. That means it's always pointing to a first node of a list, and each link is carry a data field that is store data of the nodes, and a link field called next, which used to connect to the next node by using its next link. And last, link always carry a link called as now to mark the end of a list. So basically, link has 4 basic operations. The first one is the injection. That means that adding a new node inside a list, that the in front of and the behind of a new node will connect the new node together by using the next link. And the second one is a deletion, that user have to choose a target node first, and after that the in front and the behind of a target node will link together after the target node have been removed. And the third and the fourth one is the display and the search. So the display is just display all the data of the list, and the search is searching the data inside the list. Okay, now we are going to show some example of list. Okay, first we're going to show how to create the head nodes. Okay, first we're going to create a new node that equals to head, that is called by head, and seen as x. And then the head point to the data equals to x. That means the x is now the data field of the head. And then the head point to the next equals to now. That means the next node of the head is equals to now. And how to create a find node? And we're going to do it by using looping. First, we create the temp as a new node and cin as x. And the temp is point to the data equals to x. That means that x is now the data field of the temp. And temp pointing to the next equals to now. That means the next node of the temp is now. And head pointing to the next equals to temp. That means that in front of a temp is the heads. So this one will keep looping until it's create the find nodes. Okay, deleting a nodes. Okay, first we have to set the temp equals to head. So the temp will now stay as the same position with the heads. And if the temp is not equals to now, so that means that temp is not last one, the head will equals to the temp pointing to the next. So the head will now move to the next node of the temp and then delete the temp. That means the first word now is deleted. Okay, now we are going to talk about how to add a new node into a linked list. Okay, first we ask user to enter the data they want to insert, and we seen into Y. And then we also ask the user that the new nodes they want to insert before which node, and we see into Jack. Okay, first we set the temp equals to head. That means the temp now is at the same location of the heads. And while the temp is not equals to now, and the data of the temp is not equals to Jack, we set the previous equals to temp, and we set the temp to the next node of the temp just now. And if temp is found the data of Jack, we will create a new node called ins, and we set the data of the ins equals to Y. And ins point to the next of the temp. That means we set the ins in front of the temp. And head point to the next equals to in. That means the next next node of the text is equals to int. Okay, so this is how it works. So first we set the temp equals to head, and while the temp is not equals to now and is not equals to data jack, we set the previous equals to temp, and the temp is now at the next node of the temp just now. And while if find the data jack, we will create a new node called int, and we set the data of int equals to y, and we point the next of a int equals to temp, and now we set the head of the next equals to int. So it's how it works. Okay, last we are going to talk about the advantage of using linked lists. So linked lists are the dynamic data structure. That means they can allocating and delocating memories while the program is running. And insertion and deletion nodes operation are easily implements in a linked list. And dynamic data structure such as stack and queue can be implemented using a linked list. And it has efficient memory utilization. That means there is no need to define an initial size of linked list, and no need pre-allocate memories. And item can be added or removed from the middle of a list. So this is all about the linked list, and thank you.